Please welcome Autodesk evangelist, Lynn Allen.
Thank you. Thank you. Are you sad that I don't have stormtroopers? Yeah, so come on, the stormtroopers were cool, right? I know, I was just thinking if all those mean kids in high school could see me today, they would think, that's cool, yeah. So, and I'm gonna tell you, they first told me that when I came out on the general session, they were gonna escort me with stormtroopers, they said, well, that's if we can get stormtroopers because it's high season for stormtroopers. And I did not know there was a high season for stormtroopers. So it turns out that, of course, with Star Wars opening this weekend, right? This weekend? Next weekend? I'm a failure. Look at you guys all know. It turns out that all the stormtroopers today are actual big Star Wars fans who actually bought stormtrooper outfits, and then they realized they could make money as stormtroopers. No lie. And when we first had them coming up on the stage, we had stairs. And it turns out, just so you know, stormtrooper outfits don't bend. So they were all like falling up the stairs, and we thought that was a bad way to start the show. So they built a ramp specifically for the stormtroopers. So there's a little background for you. And where are my freshmen? Oh my God, that was terrible. Where are my freshmen? Are you already exhausted? You got 3 more days or 2 more days, right? All right, that's better. That's better. Well, welcome, welcome. I hope everybody's been extra nice to you and that you felt right at home at Autodesk University. So can we go to the next slide? Oh, he's like, really? You have the clicker. Sorry. Can I go to the next slide? Thank you. Thank you for doing it for me. Okay, all right, so this morning you heard, of course, from Autodesk in the general session, and tonight we're going to get to hear from the sponsor technologists as well. So I'm just going to give you a lowdown on the night. We have 6 total technologists. 5 of them are from our wonderful sponsors, and 1 of them is from Autodesk. We changed it up a little bit this year, and we also have a technologist from Autodesk. I think I played it in the past, but now I'm just playing one of the movies. So the best part is each of the sponsors is going to give away a free pass to next year's Autodesk University. Okay? And we know you're not here for that, and we know you're not here for the drinks. We know that you're here for the technologists. So we have 3 questions that we're going to be asking each of our technologists. Well, kind of technically 4. One of them is a fun question. And each person is going to have their own little timekeeper going. So we'll keep the answers nice and short and sweet. And pretty much the questions are going to be based on the themes that we heard in the general session. So that's kind of the way the flow is going to go. So let's meet our wonderful technologists. Would you please welcome to the stage Stephen Orban from Amazon Web Services, or AWS if you want to be cool. And I want to point out his fabulous socks.
It's the only part of my outfit that I'm still allowed to pick out, so I like to have some flair.
Kill him. Your wife would be proud.
Yes, indeed.
And then from Autodesk, one of my favorite people at Autodesk, he's absolutely amazing, Brian Penne. And then from Dell, we have Rahul Tico. Rahul, come on. Keep the energy going. And then we have someone who's been on the stage with me many times at the Technology Trends, and that's Bruce Balejo, which I got his name right this year. I think I've actually ruined it every year. Am I right? Like every year I got it
Nicely
wrong.
done. Thank you, Lynn.
It only takes me like 3 years and then I get it right. And then we have from Intel, we have Mark Seeger, who's new this year. Welcome up, Mark. And then from Lenovo, we have Victor Rios. Thank you. You guys see my Band-Aids falling off? Too many high-heeled days there. So, actually, before we get to the first question, I want you to kind of get to know these guys. So we'll just go straight across. We'll start with you, Stephen. And we'd like you to introduce yourselves. Even though we just brought you up on the stage, kind of tell us what you do for your company. And then for the fun question this year, we're going to ask you, if you could be any superhero, who would you be and why? just to kind of break the ice a little bit. All right, and we haven't, I have no idea what they're going to say. We haven't even rehearsed any of this. So I'm going to sit and enjoy. Let's go ahead and start with you. I'm like losing.
Sure. Thanks for having me, Lynn. So my name's Stephen Orban. I joined AWS as head of enterprise strategy in September of 2014. So I've been in this role for about 15 months. Prior to this, I spent 3 years as the CIO of Dow Jones, where I led some pretty substantial IT transformation, of which AWS was one of our key partners. And in my role today, I spend it in 2 key areas. One is traveling around the world and talking to CIOs and CTOs at the largest enterprises in the world about what the organizational impact cloud adoption will have on their organization and how they navigate that change. And then taking what I learned from that and iterating and optimizing on our go-to-market strategy for the enterprise. If I had to pick a superhero, I'm going to take a little bit of a different tact on this. I'd probably pick Iron Man, only because I'd like to have unlimited resources to work on my own nerdy tools and bag of tricks to give back and help the world in some meaningful way.
Okay, we have one Iron Man. All right, and Brian, really one of the coolest people at Autodesk. Brian.
Yeah, so I'm Brian Penne. I'm a director of emerging technology. I work in the office of the CTO. And what I do to justify my existence there is really we look at emerging technologies and emerging trends and look at where those intersect and try to draw a dotted line down to our customers. So we build a lot of prototypes. We're looking at things in augmented, mixed virtual reality, gamification of design, real-time simulation, and so forth. And I'm really excited to be here.
Oh, favorite superhero. Oh, no, if you could be any
my favorite
superhero, or who you would want to be if you could be a superhero.
I'd probably be my wife with her amazing powers of persuasion. No, just kidding. I'm saying she's watching.
Is she watching?
Yeah. I'd probably be Thor, because he's just got so many cool superpowers. He can fly. He's got regeneration. He can control the weather. I'm a klutz, and I need that regeneration power. So. Yeah.
And he's hot.
And he's
sorry.
Okay.
I was only for the women. Only for the women. I'm sure he looks just like it's. Anyway, let's move on. All right. He's a great superhero. I'm just saying.
All right.
Okay. All right, Rahul, you're on.
Yeah, so I'm Rahul Tikku. I run the Workstations product group at Dell. I'm a technologist. I've been a technologist all my life. Been at Dell about 3 years, and before Dell, I worked at AMD, running the server products division at AMD. So, I thought I'll break from the rest here, and I'm going to pick not a superhero, but a super villain. So if I could be...
You could be a villain? Oh, Dr. Evil! Seriously?
$1 million. Well, the bad guys get to have all the fun. So,
he does get to have a lot of fun. Okay, if you're going to pick a bad guy, he is the coolest of all the bad guys, I have to admit. Okay, all right.
I just don't have the hair for it.
Thank you, Rahul. Bruce, you're on.
Hi, everybody. I'm Bruce Balejo. First of all, I want to thank Lynn and Autodesk for having me back this year. I think this is my 4th Tech Trend session, and they get better every year. So thanks, everybody, for coming out. It's fantastic to see how jam-packed it is. So I'm with HP Inc. I'm the chief technologist for the workstations business. I've been with HP for actually 30 years, which is kind of amazing to think of. My focus is on new innovation, not too unlike Brian, emerging technologies, new innovations, new product ideas to focus on helping people get their jobs done quicker, better, more productively. So as far as superheroes go, I think if I had my pick, I would probably pick the Dark Knight, Batman, probably for a couple reasons. One, I'll admit I grew up watching the old cheesy Batman TV show with Adam West, for those of you old enough and willing to remember and willing to admit it. Also, he's a self-made man, right? He doesn't actually have superpowers. He just uses his brains and abilities to make himself into a superhero. And plus, most of all, he's got the coolest gadgets.
He does have cool gadgets. Thank you. Thank you so much, Bruce. Okay, perfect. Batman. We have a Batman. Mark?
Mark Seeger. I'm an Intel fellow and CTO for the technical computing ecosystem. That's a mouthful. And what I do for Intel is look across the broad swath of products and figure out solutions for the technical computing ecosystem from the volume space all the way up to the next generation of supercomputers, which are called exascale class systems, probably be available in the 2025 timeframe. As far as a superhero, I have to reach back into my childhood. When I was about 4 to about 7, I was Superman all the time. Wore a little T-shirt with an S on it because then I could be Super Seeger. And besides that, the cape was pretty cool, and I love to run. The other reason I like Superman is he was a really nice guy.
He was a really nice guy. Okay. And then, not that I know him personally, but anyway, he seems like a nice guy. Random comment. Anyway, and last but not least, Victor.
Good afternoon. It's nice to be here. It's my first time. You can see my green freshman badge. I'm the Vice President and General Manager of Lenovo's Performance Computing Division, so I have 2 jobs. My day job is I run the workstation business, and my night job is I run our gaming PC business, which we're just kicking off in the last few weeks. It's really exciting, to see all the technology and all the people here. It's amazing, the crowd here today. If you ask my superhero, I guess my superhero would be Spider-Man. I've always liked Spider-Man. Unfortunately, not as hot as Thor, Lynn, but I really like the fact that being in something related to the PC business, anybody who can take a hit and fall off buildings and always land on their feet, I think that's a good skill to have when you're in the business that I'm in. So that's why I picked Spider-Man.
That's a great answer. All right. Not as hot, but he's still cool. He's very cool. I was a big Spider-Man fan growing up. All right, so just so you know, we don't have an order. This is totally random. So it's pretty much, as they decide to answer the questions. It's just to kind of keep it a little more exciting instead of going down and answering the questions, which really is not that exciting. So the very first question, which we have up on the screen, you've been able to read that for a while, is how do you see technological advances impacting the means of production when considering the future of making things? And then who?
So, Mark Seeger again. So, in the HPC space, I was thinking back over my career, at Intel for 4.5 years, and before that at the Lawrence Livermore Lab for 28 years. And in the last 20 years or 25 years, we've gone from 50 gigaflops to 20 petaflops. That's a factor of 10 to the 6th in computing capability. And from that, we went from 2D low-res models that could basically interpolate in between data that we had from experiment to a fully 3D, full physics, predictive simulation capability. And what we see coming in the future is even a more accelerated advance in computing technologies into the exascale era, which will be another 10 to the 5 factor of computing capability by 2025, as I mentioned earlier. That's just an amazing amount of computational power. And we'll be talking about data, big data coming from the Internet of Things and other stuff. So the combination of predictive simulation capability and predictive data analytics capability mean today the products that we can develop were not even conceivable, 15 to 20 years ago. And when you think forward to the exascale era, I keep telling people, you're not thinking big enough. We've gone to 3D simulation capability. We're now doing multi-physics simulation capability. We're combining that with big data at the beginning to go after some really strategic problems, like the global climate change challenge with global climate modeling, like precision medicine, where we are on the verge of having the capability of taking DNA samples and protein samples from individuals and doing genomics and proteomics, big data analytics calculations that would lead to a simulation of the chemical transmission pathways in an individual cancer patient that would mean that we could figure out where to block that transmission for individual cancers. Those types of breakthroughs are absolutely phenomenal and will, I think, impact the lives of everyone in this room, hopefully before we die.
Yeah, it's wonderful. I hope so too. Who else would like to?
I can go next. So, if you look at today, the maker movement, this is the best time for the maker movement, right? I mean, we've democratized technology completely. I mean, if you look at just 10 years ago, 20 years ago, we were talking about Unix-based workstations. Who here has used Unix-based workstations, right? $20,000 workstations to go do some of the work that we do today with under $1,000 workstations with cloud-based software delivery. And so as we have democratized the technology, we've brought in a whole new class of creators into this space, right? They're creating globally, and you know, that is what the maker movement is all about, right? Is it being able to go bring global creators into the mainstream. So
that's great.
Yeah. So I'll take the next.
next
So,
one.
I mean, obviously, there's going to be increased productivity. You're going to see lower costs. You're going to see increased automation. But I think the fundamental changes that are happening right now, technological advances, are, you know, in design. They're happening in production and manufacturing, and even in simulation. I mean, an example of this would be, you know, generative design for, you know, producing a model where you can actually accept the constraints. So designers focus more on constraints, and then let the computer simulate the most optimal design, and I think that can help a lot. And then in manufacturing and production, one example we're doing at Autodesk, how many of you have heard of Pier 9, our facility in San Francisco? So not many. Pier 9, what's really exciting about that is that's an entire facility. It's a non-production environment. It's right there in San Francisco on the bay. And we have, you know, 11-axis Moriseki CNCs, laser cutters, every type of 3D printing, laser editing. And the reason we do that is because the software to actually manufacture, or the software that talks to the machine, isn't always easy to use. So we want to increase the productivity going from design and letting people who don't always know how to do that kind of work produce that. So we have an AIR program. We let people really push on amazing ideas and produce things that they wouldn't have thought possible. And a lot of that's done in a non-production environment with really high-end production equipment. And that's stuff that I think we believe fosters innovation. And so seeing that along with all the cloud computing simulation that's going on, and then just, you know, all the increased mechatronics and automation is going to really, I think, revolutionize what we'll see in the next 10 to 20 years.
That's great, yeah. If you ever get a chance, if you're in San Francisco, Pier 9, absolutely fascinating. Very, very talented individuals there. All right, actually I told Victor he could go next, and you can go after that.
Yeah, so Lynn, you know, there's two areas that I think that I'm very interested, very excited about. One, you may saw the video before we got started. Of course, many were getting drinks and snacks before we started, but we do have a partnership with Autodesk and a company called MX3D in Amsterdam. And the collaboration is they're actually using 3D printing to print the world's first 3D printed bridge with steel over a canal in Amsterdam. We sent some of our members over to Amsterdam in the last few weeks to check on the progress, and it's absolutely amazing that you can see the capabilities they can do that's never been done before with technology. So when you see this large-scale use of 3D printing, it's amazing what could be done with that. The second is on, you know, augmented and virtual reality. It's very, very clear for virtual reality, you know, in our gaming space and the fit, and this is going to really explode as this comes on full bore into next year. But when you start looking at designers and manufacturers, and you look at augmented reality, and you look at the capability for designers to collaborate and to share and to really kind of blend together the physical and digital worlds, we think this will really create the next generation of exciting products that I'm sure each one of you will appreciate as you go forward in the future.
Yeah. I'd build on a couple of the points that were just made. The first is, and then maybe take an angle of how the cloud is really kind of ushering some of these capabilities in. The first is, you know, with automation really driving up productivity and driving down cost. And I think it's fairly well understood at this point that if you can reliably reproduce, in particular, your software systems, you can scale them up and down automatically using some of the great technology that, you know, that AWS has brought to market. And what I think is really fascinating about how automation has really helped the software industry explode over the last 20 years is really a lot of these concepts have come from the makers and have come from the manufacturing discipline, where, you know, in the mid-20th century, in particular, Japanese manufacturing really codified this concept of Kaizen, or continuous improvement. And, you know, that's been used in all the successful software companies that I've been a part of to really help them grow and develop their products. And the second thing I'd point to is how your thinking changes when you have infinitely available infrastructure or computing resources available at your disposal. And we just talked a little bit about generative design and the initiative that Autodesk is really the thought leader in, and really being able to give designers the ability to set constraints rather than specific designs and specs, and then run that through a platform that's infinitely scalable that will allow them to test millions, if not billions, of scenarios very cost effectively. And we see this across a wide variety of industries. In financial services, we see banks and hedge funds and money managers running Monte Carlo simulations across an enormous amount of Wall Street information. And then in healthcare, we've seen drug makers run drug and clinical trials against DNA sequences where they're doing that for tens of thousands of dollars at a time, and what would have traditionally cost them $30 or $40 million to build data centers to do that. So I think that some of those things are really thought-provoking.
Okay, great. And then Bruce.
So if you look back a couple hundred years before we look to the future, the original makers were craftsmen, and they did the design and the production themselves. And then the first industrial revolution came along, and we separated design from production so that we could get a lot more scale and efficiency out of the production side of things. And then we've continued to try to optimize both. We can use computers now and do design a lot faster. We've continued to refine manufacturing methods, but they remain separated. So I think our view at HP Inc. is in one of our key strategies is to try to drive some new technologies to try to bring that back together again, to reunite the designer with the producer. And there's a couple of things we're trying to do to accelerate that. The first and probably most obvious one is in 3D printing. 3D printing is in additive manufacturing in general is pretty exciting today, but for it to really drive a new industrial revolution, it needs to be much more pervasive. It needs to be much more available. It can't be an expensive or a boutique kind of technology. So we're working on what we call multi-jet fusion to try to bring order of magnitude improvements in getting the cost down, getting the speed up, and getting the quality much better than it is today. It's a first step in the right direction. We're also working on something we call immersive computing, which is trying to work on the design side of things to try to make it easier for people to go from ideas to bits to atoms and back again. That's something we call blended reality. So that's sort of the focus, and we think that if you do that and can make that widely available, when we get to the tipping point that that's widely available to lots of people, then I think it really will usher in a new industrial revolution. So that reuniting the designer with the producer is what we think will really change the world.
Okay, great. Thank you so much, Bruce.
Lynn, if I could add one more thing,
sure.
One more thought. I think irrespective of what industry we're in, right, whether it's automobiles, planes, media entertainment, engineering, etc., we all have the same challenges. It's schedule, it's cost, it's quality, and so even in our industry as computer makers and technology providers, we have the same challenges. We have to deal with the same challenges. And so some of these technologies are as useful to us as they are to you, right, in terms of the latest and greatest simulation technologies, being able to visualize your design before we cut tools and be able to go, cut that time and waste out of the production process, right? So it's as important to us. And so we're learning from that internally, but then applying those, to the industries that you guys are from. So.
Okay, great. Thank you so much. We're going to move on to the next question. And I just want to say the whole printing of the bridge, it's like I talk about it all the time, the 3D printing of the bridge. It is very, very cool. And my absolute personal goal is to get out there and see it in action. So I'm going to have a bake sale or a car wash or something so I can raise the funds. But it's very amazing, fabulous technology. So thank you so much, gentlemen. Let's move on to the next question. So how will exposure to global markets alter customer demands for your industry? Who would like to go first? Nobody wants to go first.
All right,
Anybody?
I'll go.
No. Go ahead.
I think, at a very literal level, right? We've been playing in global markets for a very long time now, right? So we're, if you think about Dell, we're global. We're all over the world. We supply, we have manufacturing, we have design. And so from that perspective, in a very literal sense, right, we have a lot of lessons we've learned in terms of optimizing your supply chain, optimizing your design process, and being able to go have products globally. But I think taking a little bit of a different tact, right, I think one of the things that we're seeing now is being able to do social good globally and being able to bring the power of Dell and the power of Lenovo and the power of HP and the power of some of the global companies that we have and being able to drive social good has become very, very important. So one of the things we've been working with Autodesk on is, with Autodesk Foundation and DREV, we've been enabling limbs, so artificial limbs for amputees at a fraction of the cost that they would have been available. And so you probably saw that while getting seated here. So, that kind of change is important, and we as global leaders have to go invest in that change for social good.
Right, and DREV, right, they have the Jiper knee, right? The $80 prosthetic knee that can swivel in all different directions. They can ride bikes with it, they can kneel with it. Very, very passionate about that. That is affordable. $80 is affordable for some of these people in these third world countries that don't have the $20,000 to spend on expensive prosthetics. So, great. Who would like to go next? I know I'm not even a panelist, but
well, I'll dive in. I would agree. We've been doing global marketing and global manufacturing for many years, and different cultures and different regions have different needs, and that drives the product requirements. But I would agree. I think the biggest change that we've seen over the last few years has been the emergence of global communities. Often to do good, any kind of unifying cause can create this global community to spring up that really doesn't have anything to do with geography or cultures. An example of that that I'll give was the video we were playing before we got started here, Project Sloan. HP is working with Autodesk, NVIDIA, some architectural firms, and Heritage Museum to basically reproduce. If you saw the video, the Bank of England in 1925 was destroyed in order to make way for new construction. It's been called the biggest architectural crime of the 20th century. So now we've started basically a global crowdsourcing project to try to reconstruct that digitally based on the historical drawings that exist. There's 2D drawings that exist. There's historical documents and recollections. And so we basically started an Autodesk 360 project. So anybody in the world can contribute to this. Is basically the first step of that is to create a 3D model in Revit. So that's been done. And then I think just today we announced the next step, and that is a rendering competition. So the fascinating thing about this to me and to the point of the question is that we've got this global community of well over 400 people that are contributing to the project. We have no idea who they are, where they live, and yet you've got to have this infrastructure in this project that you're managing to enable folks to collaborate, to contribute, and communicate with each other. So we're kind of using it as a living lab to understand, what are some of the limitations. There's some very good things that are available today. There are definitely some limitations to this. So we're trying to learn from that and figure out how we can make this easier to do.
Great. Thank you, Bruce. Victor?
Like my colleagues from Dell and HP, we obviously have a global footprint as well, and that's very important for us for volume, for scale, and it drives efficiency in our business. But we also know, serving global markets, there's very difference in tastes, color, size, texture. So one of the challenges we have is in manufacturing and design is that how do we develop platforms? How do we design our platforms such that we can get advantage of the commonality, but then provide the uniqueness that we need to serve our market? So that's really an important factor for our designers, from our product managers as they listen to customer feedback, from the design of our mechanical structures, from design even of our components and component selection. I think that's key. In addition, your manufacturing needs to be tailored to your local environments as well. We'd love to have all of our volume in one single plant outputting around the world, but really for delivery, for time to market, even for tax and legal implications. We need to make sure that we source our manufacturing facilities close to customers where it's needed, but also make the right balance of getting scale in our overall business.
I think,
Thank you, Victor.
sorry, what I would add is how easy it is to now become a global company and how easy it is to create products that have a global reach. And I'd point to two things. One would be mobile, which I think is self-explanatory. And now that everybody in the world has a mobile device that you can reach, and the other, of course, is the cloud. And when you look at how the cloud has come in and taken away a lot of the undifferentiated heavy lifting associated with traditional IT operations, it democratizes and levels the playing field for any company to be able to enter the game and build certainly software products, but other products as well, without having to focus on all of the work and investment that was traditionally required to have an IT department continue to power all these resources for the company. And I think Autodesk is a great example, and largely one of the trends we're seeing as software as a service becomes increasingly popular because manufacturers and makers and designers don't want to have to build all the tools that they need to make what they're making. And then I think the other thing that the cloud helps with global expansion and reach is having globally available infrastructure that's uniform across the entire world, really. And at AWS, we operate 11 regions in many continents throughout the world, and it's very straightforward to take the things that you build in one region and move them to another. Just as an example, speaking from experience, when I was at Dow Jones and we had moved the Wall Street Journal and MarketWatch onto AWS and had everything fully automated, we were literally able to, in a couple of minutes, expand our footprint from just the US to also Europe and Asia in literally a few minutes and a few clicks of a button. And lower latency for users, get closer to them, better understand how they're using the system and be able to scale a lot more effectively than we would have been able to before. And these are things that just aren't tenable when you have to be investing in your own colos or data centers all over the planet.
Great, thank you.
And I think the only thing I would add to this is, what we're seeing, at least from Autodesk, is just the emerging global markets that we see from, Brazil or Russia or, all of these people are more affluent, they're higher educated. I think they're expecting a greater demand in productivity. And the fact that we have a lot of our products now in the cloud as well as available, offline and online for people, they can really explore that. And with those more choices and those more abilities of using technology, they can solve a lot more design and engineering problems and challenges throughout the world.
Great, thank you, Brian. And Mark.
So in the high-performance computing space, the perception globally now of the value of predictive simulation capability coupled with machine learning and other big data analytics capabilities is driving multiple government agencies across the globe to announce exascale projects. And that ranges from the United States with the President Obama signing in March a national supercomputing initiative being led by the U.S. Department of Energy, DoD, and NSF, to the EU Horizon 2020 program, to the next generation of supercomputers being designed in Japan, to the next 5-year plan with an exascale roadmap in China, to Australia creating a simulation capability for the Square Kilometre Array project. But the best project I've seen so far is the CDAC project in India, where they're going to spend $3 billion to democratize HPC by creating a workstation infrastructure connected for researchers across the country, connected to a very high-speed international and national backbone, with 5,000 small centers that are all in the 10 teraflop kind of range, to 3 regional centers which will be in the 1 to 5 petaflop range, to 2 national centers which will be on a race to exascale. So this is a broad-based program that is training for India the next generation of engineers and designers, but also code developers who will be developing an indigenous simulation and predictive data analytics capability for for India. That is a huge transition that we've seen in the last 10 or so years, and it's really come about since Council on Competitive, the U.S. Council on Competitive, identified that it's actually a national priority for the United States to be globally competitive. We actually have to outcompete by outcomputing, and that message has gotten out across the world, and there's now a real recognition to go after those capabilities, regionally.
Great, thank you so much, Mark. Thanks for all your great answers, gentlemen. And the last question that we have for you, which is actually my favorite question. I'm a huge fan of all the possibilities that the Internet of Things brings to us. So how do you see products changing in response to the Internet of Things? Who would like to go first? Brian's jumping in. I see him. Sure. He's ready.
Yeah, I think if you guys saw the main stage sessions today, our products now, we have all these abilities to sense. And products don't just learn about they learn about their environment, they learn about all these other things. So product lifecycle is not going to end when a product ships anymore. And I think people are going to be really interested in what happens after that product ships. An example of this would be kids playing with toys. How they play with that toy, what they do with that, how they consume it, when they dispose of it is going to be really interesting data for people to understand how their product actually behaves once it's in use. And I think that's a really exciting time. And the other exciting thing about this is we have the ability now, once we can capture all of this data and analyze it and make sense of it, we can use it as a feedback loop into our designs and into our systems. And doing that makes not only better designs, but happier customers. I think Jeff today on main stage mentioned even, why don't they know when I'm in the bathroom not to disturb, me, or any of these other things. They're really straightforward, simple things to know. With a very small, low-cost sensor, but we're not doing them. And I think the more we can do those and the more we can leverage that data and how they're used, how they're manufactured, and how they're shipped, the better designs we can make in the future.
Okay, great. Thank you.
I need the sensor for the bathroom for my kids. Do not disturb.
Exactly.
Yeah. So I'll reference one of Jeff's other examples this morning, and that was the example from the Seattle airport where they ran out of the de-icing fluid. HP is taking that same idea with some of our newer printers. We have sensors in the printers that will detect the ink level, and we have a service program called HP Instant Ink, where the printer will monitor the ink levels. And when your ink starts to get low, it'll basically phone home and go back to a cloud service and basically cause an ink cartridge to be sent to your home. It's a subscription model, so rather than having to go out and figure out when you're getting low on ink and go buy it, it'll be sent to you automatically. It does a couple things for you. One is it's generally lower cost. The big thing though is it's convenient, and the other thing that was interesting, we didn't know how this would go, is we found that people that have the service actually do more printing because they feel confident. You have a certain number of pages per month that you're allowed, and there's also no penalty for color or rich printing. So people print a lot more color when they're on this program. So it's all enabled. Starts with the sensor, so it gets back to it's these different business models enabled by IoT. Another example that I would like to see that I haven't seen enough of yet is IoT linked to augmented reality. Imagine, if you will, buildings with sensors embedded in the walls that could tell you things like the locations of the pipes, or operational data like flow rates, temperatures, things like that. I haven't seen that done extensively yet, but I'm looking forward to it. And then the third example, and probably my favorite, actually comes from a customer of ours, a company called Zebra. They do RFID tracking tags. They have some exotic applications. They're a provider to the NFL to track football players, but the one I love the best is they track livestock. I call it IOC, the Internet of Cows. It's like, so why would you want to track a cow? A few things are obvious. If they get lost, when the mother cow is going to give birth, a lot of times they go hide, so it's good for the farmer to know that, so they can go track them down and be there to assist if they've got some distress or they need to intervene. But the most fascinating part of this, and this is a real common theme, IoT leading to data analytics, is that they can, by tracking cows, you can monitor things like how long they're spending at the trough. They can actually figure out how much water they're drinking, and it turns out that correlates directly to how much milk they're going to produce in the future. So if you aggregate the data from multiple farms in a region, you can actually very accurately predict how much milk is going to be produced in the coming weeks, which allows you to predict market prices. So you go from an RFID, cow tracking technology to being able to sell data to farmers to predict, what the future price of a commodity will be.
Okay, thank you, Bruce. The Internet of Cows. So, it's pretty fascinating technology. But we'll do Victor, and then we'll do Stephen after
Yeah,
that.
another area of optimization that people don't normally think of is power distribution and control. I worked on a project while I was at the Lawrence Livermore Lab where we were working with PG&E, and we found out that not very much of the Western grid is actually known digitally. It's all on maps and stuff. And when there's an event like an earthquake or a big storm that comes through, they actually put maps on the wall and put string on the regions of the grid that are down, and they make very conservative decisions about what part to shut off to stem the grid shutdown off. Reverse of that is that there's no capability to do design optimization of how to bring the grid back up and which parts to repair first. And it's all 50-year-old engineering expertise that does those calculations on the back of an envelope, and those people are beginning to retire. So they're looking at instrumenting the grid, they're instrumenting wind towers and other means of production, and so that combined with very accurate sensors for real weather data allows them to do accurate prediction of what resources will be needed in terms of gigawatts produced in California, for example, on the next day. And that they typically now have a 10% differential between the predicted usage and their standby power, and those are jet engines and other nuclear reactors that are basically idle, waiting for the demand load to go up, and that's an engineering safety band so that the grid doesn't burn out. Right? If you can accurately predict, within a couple tens of megawatts on a 50 to 60 gigawatt scale, what the demand is going to be, you can drastically reduce the standby power that's required to optimize that grid, and that reduces the wear and tear on those machines. It reduces pollution and makes electrical generation power distribution way more efficient. So fundamental shifts of things that we have taken for granted as legacy industries will be transformed by the Internet of Things.
Okay, thank you very much. And we're going to Victor, and then you. Oh, sorry, Stephen.
Yeah, I just want to follow on to what Brian mentioned earlier. Really, at Lenovo, it really is important to get data to improve the quality, performance, and even the optimization of feature in our products. With user acceptance, obviously, we're able to collect data to tell if drivers are not performing properly, can we provide a new driver to the end user to speed up their performance. If a particular user is having a particular quality problem or something is not set up properly, can we understand that quicker and more timely to make a better product for the end customer? And finally, feature optimization. If we find that through data that a feature is not getting used, or maybe it's confusing, we can help that user understand the feature better, or possibly for a new future product, we may eliminate the feature altogether if we see that candidly it really is not being used by the end user in our initial expectations. So the data and the learning is fantastic for us. I would tell you though, a challenge for you as you look at that, I think the first step is collecting the data. I'm collecting the data and understanding it. But probably even more importantly is how do you analyze it, and then how do you get it to the right people? We collect a tremendous amount of information, but how are we able to get that down in a very usable format and getting that directly to the product manager, the engineer, etc., to take action on that and improvement is really a key next step for us to really optimize the performance end-to-end for our customers.
Great, thank you, Victor. And Stephen, and then you start.
Yeah, I'd give two pretty selfish reasons for really being excited about IoT. One's personal and one's professional. And personally, I work really hard. So when I'm home, I want to spend time with my kids, or and my wife, or I want to be lazy. And having a connective home where I have to do less sort of work to upkeep my house and worry about where the lights are on and what's in my refrigerator and how it's automatically being stocked, or where I can tell my Amazon Echo, hey, I need some paper towels, and my Amazon drone comes and delivers them to my house 2 hours later. Or I get low on milk, and that automatically gets ordered and shows up on my door right away. I mean, that's to me, like, that's going to be a huge life improvement, because then I can focus more of my time while I'm at home on the things that matter. And professionally, again, a little bit selfishly, I'm a software developer by trade and background, and I work with a lot of developers and data scientists. And to build on the last point here, I think, the IoT revolution is going to force companies who make and generate products that are connected to the internet to really consider how they're going to build their software competencies. And how are you going to, first of all, manage all that data, collect it, and then to the previous point, do something actionable with it. And we were very excited to launch our IoT platform a couple of months ago here at this hotel at reInvent, which is really going to help makers and companies alike do that. And I'm really, really looking forward to the advancements that's going to have, both for me professionally in my career and also to make me lazier at home.
Good. Well, did you?
Yeah, so, 50 billion devices connected by 2020. I mean, that's what the industry is predicting. And like my colleagues here said, right, I mean, that generates decabytes of data. I don't know if that's even a word. But so Internet of Things is really Internet of data. We're all going to be in the business of data, right? We're all going to be working with data, trying to figure out, how to store it, how to secure it, how to compute, how to analyze, and how to deliver the right experiences using that data, right? So, if you look at Dell, we've been investing in this space for quite a while in terms of the security solutions, in terms of storage and server solutions, in terms of workstation solutions. And then most recently, we announced our Edge Analytics solution, which takes this data and makes some smart decisions real time with the data. So you're not sending decabytes of data back, maybe you're sending decabytes minus one data back, right? So real-time decision making is going to be important. And then I'll leave you with this thought, right, is products are not going to be any more about physical products, right? It won't be about Dell giving you a server, right? It's going to be about product clouds, right? The services, the software, the experiences that we're able to deliver online once we deliver the physical product to you. That's going to be more important. That's going to change business models, and that's where the industry is headed.
Okay, thank you. Thank you very much, all of you. And I think for myself, I expect products to be smarter, and I get very frustrated when they don't live up to my expectations. And I think as time goes on, we're definitely going to expect our products to be smarter and smarter. So it's really a pretty fascinating technology. So first of all, I want to say we have competitors on the stage who have been so gracious and so nice to each other, and I think it's really true that we're focused on making products that are going to make your lives better, but I'd love you to give a nice round of applause to these fabulous gentlemen.